Sum number 4. Given that HCF of 306, 657 is equal to 9, find the LCM of 306, 657. So here the two numbers are given, 306 and 657 are the two numbers, and they had given that HCF of these two numbers is 9 and we have to find the LCM of these two numbers. So actually we know the relationship between the HCF and LCM. So what is the relationship? It is nothing but HCF into LCM is equal to product of two numbers, is equal to product of two numbers. So what is HCF? HCF is nothing but 9 into LCM. LCM we don't know, equal to product of two numbers. What are the two numbers? 306 into 657. So the two numbers are 306 and 657. So since the word product of two numbers is there, no, so we are multiplying these two numbers. So 306 into 657. Now LCM is equal to 306 into 657 divided by 9. This multiplication part will become division part. Okay, so now let us cancel this. So when we cancel, we get 3 3s are 9, 3 1s are 0, 3 2s are 6, and then once again 3 tables, 3 1s are 3 3s are 9, balance 1, 3 4s are 12. So 34 into 657. So this gives 22,338. Sum number 5. Check whether 6 power n can end with digit 0 for any natural number n. So we have to check whether the number, that is the 6 power n, this can end with the digit 0 for any natural number n. So you just consider, so first what is 6 power 1? So 6 power 1 is nothing but 6, isn't it? 6 power 2, it is nothing but 36. So 6 cube is 216. So like that, if you consider 6 power n, we can see that the number will end with 6. Okay, so 6 power 1 has 6. 6 square, the number which is at the end is 6. 6 cube, it is also ending with 6. So similarly 6 power 4, 6 power 5, like that, if you consider up to 6 power n, definitely it ends with the number 6 only. Okay, so now you just consider, first we are going to consider a digit with 0. Consider a digit with 0. So consider a number which ends with a digit 0. Okay, so if we consider a number, for example, if you just consider 10. Okay, 10 is a number which has 0 to be the end number. So 10 I can write it as 2 into 5, isn't it? 10 I can write it as 2 into 5. Now you just consider 20. 20 we can write it as 4 5s are 20. This 4 can be further simplified as 2 2s are 4. So 2 into 2 into 5. And if you just consider 30, we can write it as 3 10s are 30, or we can also write this as, okay, 3 10s are 30. So this is equal to 3 into 10, we can write it as 2 5s are 10. And similarly, if you consider 40, we can write it as 4 into 10. So this 4 can be further written as 2 into 2. 10 can be written as 2 into 5. Now you just see in all the cases, 2 and 5 are presented in 10, 20, 30, 40. Okay, so we can observe that 2 and 5 is presented everywhere with the number which is ending with 0. Okay, so now if you consider 6 power n, so 6 I can write it as 2 into 3. 2 3s are 6, the whole power n. Okay, so this n is a natural number. This n is nothing but a natural number. This 6 power n, it contains 2, but it is not having 5, isn't it? But it is having only 3. So for all the numbers, which is having 0 to be the n number, 2 and 5 as the numbers, as a product, isn't it? But here for 6 power n, we are obtaining only 2 and 3. We are not having 5. So we can say that since 5 is not since 5 is not here, 6 power n can never end with 0. Is it clear? So if you consider a number which ends with a digit 0, we can see that this number contains 2 and 5. Okay, but for 6 power n, the 6 power n can be written as 2 into 3, or we can also write 1 into 6. Anyway, that 6 will be factorized, and it once again we are left with the 2 and 3. So 2 and 3. So we are having 2, but 5 is not presented here. So we can say that 6 power n can never end with digit 0. Okay, so this is answer for sum number 5.